We have seen that alternating voltages vary sinusoidally and thus are represented by such an equation. Here this is the amplitude or the peak value of voltage, and this is the angular frequency of oscillation, which is equal to 2 pi into the frequency of oscillation. Now, this equation is similar to the equation of SHM we have already studied, where we had seen that an SHM can be considered as a projection of a uniform circular motion. Similarly, we can represent alternating voltages as the projection of a vector rotating anticlockwise about origin. This is called a phasor diagram. Here length of this vector is equal to the amplitude of voltage, and it rotates about origin with constant angular velocity equal to omega. For this course, we will use the convention of using capital letters to represent the amplitude or the peak values or the maximum value of the sinusoidally varying quantities. And we will use small letters to represent their instantaneous or time varying values. Projection of this vector on the vertical axis gives the instantaneous value of voltage. That is, it gives the equation of time varying voltage. At some point, instantaneous voltage of source is 0. Then it reaches a maximum value with polarity in one direction, decreases back to 0, and then reaches a maximum value with reverse polarity, and so on. Also, we will explore in this chapter that when a source of alternating voltage drives an alternating current in a circuit, then voltage and current are generally not in phase. That is, they do not achieve their maximum values at the same time and do not become 0 at the same time. We had also discussed that when two SHMs have a phase difference, this means that their corresponding circular motions have a phase difference. If we represent this SHM by such an equation, then this SHM, which is behind the first one by a phase of phi, will be represented by this equation. If we plot these equations, then this SHM will be shifted towards right by an equivalent phase difference of phi. As this graph is in terms of time, and one cycle of 2 pi rotation is equal to time period t. So the graph of this SHM will be shifted by this amount, and it will be shifted towards right because it will achieve its maximum value after this SHM achieves its maximum value. If this SHM was ahead by a phase of phi, then its equation will be like this. And as it achieves its maximum value before the first SHM, so its graph will be shifted towards left by an equivalent phase difference of phi. AC voltage and current in circuit have the same angular frequency but different amplitudes and are often out of phase. If current lags voltage by a phase of phi, then in phasor diagram, the amplitude vector of current is behind the amplitude vector of voltage by a phase of phi. And graphically, current will be shifted towards right by a phase of phi. If current leads voltage by a phase phi, then the amplitude vector of current is ahead of the amplitude vector of voltage by a phase phi. And graphically, current will be shifted towards left by a phase phi. And sometimes, when the voltage and current are in phase, they are represented like this. We take the standard equations of an AC voltage and current like this. Here we assume that the current lags voltage by a phase phi.